Hi, this is Dr. Taheri. Welcome to another SolidWorks screencast. Today we would like to talk about advanced mating, gear, rack and pinion, and other mechanical mating. So let's just start with opening an assembly. And at this stage you don't need to bring any parts. I want to do a few drawings first. I make a few circles and then start to bringing parts. So we make one large circle with the diameter of 200, one with diameter of 100, and then here one with diameter of 50, 150 here, and then all the way down we go and we make one here with diameter of 50. Let's just add the dimensions here as I mentioned. So this is going to be 200, this one is going to be 100, and these two each would be 50 millimeter diameter. So we do some tangent relation here. This circle and this circle to be tangent, so as this and this to be tangent, and then we make final diameter distance of between these two to be 300. The next step is now we go to design library, and you can select what country you want, and from there I go here to power transmission gears, and I start to bring gears. So already made here, so this is a gear. I just drag it here. As soon as I bring it, it would go to toolbox component and ask about the configuration of this gear. Two most important parameters are, one is the module, one is the number of the teeth. So if I want to have a gear with a diameter of 100 and a module of 2, obviously I need to have 50 gear. Next is you have two choices for the pressure angle, 20 or 14. You can see the difference here is slightly sharper. Let's stay with 20. The face, you can make it 20 or 30. This is the face, and then you can have three types of gear, either without any hub, or you can have hub in one side, which is here, or hub on both sides, which is look like this. So let's just stay with the hub in one side, and then the diameter of the hub would be in this case 50. The length would be 50, and now you have the diameter of the shaft hole here 10. You can have 1 or 2 square keyway. So this is good. Let's stop this here. Confirm the configuration. It might take a few seconds to bring it here. I don't want to make the second one here, so escape key. When you bring apart the first part, by default is a fixed part. You want to float it, move it, then you have to go right click and choose float. I did that now. I select this cylindrical surface and make this width this circle opposite side. This is the front face, and I made it with the front plane. This is done. I'm gonna bring two more gear for these two and one for the bottom. So bring one here. They always bring the previous one in the configuration box. So for this one, of course, I have to change a few things. First of all, the diameter of this is 50. As a result, I go to 25. That's one thing. And I do not need a hub for this, so I'll take it off, and assuming the rest is good, okay, and I bring duplicate two more, 1 and 2. Now the third one is going down, so right here I go and right click on the third one, and I go to edit toolbox, and for this one I want to add a hub, because then I'm going to mate it with the one on the bottom. So this is type B. Of course, the size of the diameter of the hub is way too much, so previous one was 50. I make this one 10. The rest stays the same. and done. um, I don't know why it didn't do it. Let's do it again. Can go here, right click, edit toolbox, and type B, and here is the hub. Type B, the diameter of the hub. Oh, the diameter is way too small, so let's make it 25 here. Yeah, because this is 10 is the diameter of the inner shaft. Make it 25, and because the shaft is 10, yeah, that was the reason actually. There we go. So now let's just start to doing the mating between these two gears here. First, I select a cylindrical shape here inside, mate that with this, and then face mated with front plane. Done. This cylindrical shape, mate that with the other circle, and then front plane here, coincident. This is done. However, these gears, they are rotating independently, so I have to go and make a mechanical mate. So I usually go to the front or normal plane, so here, and move one of the gear accordingly. So maybe move this one here and put it in the right position, which is like here, for example. And then you go and use mate. We want to mate it mechanically. So one of the options is gear, and you select this face and this face. It could be this line or edge. So obviously the ratio is 1 to 2, 3. So 1 to 2. So this is 50. This is 100. I could have written here 50 and 100 as well. So this mate is done, and you can see that by moving this, the relation is there. Let's do the same thing here. Now I can move this one in this position, and again gear mate. I go and select this face and this face, and again the ratio is 1 to 2. Done. The relation is here now, and now all three of them are connected. So if I move this one, the other one moves as well. Since I'm here, I'm going to bring an internal gear, and this one obviously has the diameter of 200. Therefore, if I want to stay with the same module 2, I have to have 100 gears, which I have here. The rest is the same, and all I need to do is do a couple of mates here. Only one gear is enough, so I mate this face and this face, this face and this line, coincident, and then I select this face and front plane, coincident. Now I have to go and I have to make the relation here. So move this one here. I put it in a proper position, and then selecting this edge and this edge, and bear in mind that now for the gear, the ratio is 1 to 4, because the diameter of the small one is 50 and the big one is 200. In this case I have to use the reverse. The motion is reversed here. Let's see how it turns. Done. And if I look at from this distance, if I move one gear, all other three gears are in motion. For the next one, same concept. You go and select a circular or cylindrical face, and here I think I didn't change the diameter of this one here. I can do it now. So let me go here, and I have my drawing here. Yeah, I didn't have the right diameter. So here, simply I can go here, and this one is the same diameter as 50. Good. And obviously the gear is exact same size as here. So let me go to the last mate I made, which is this mate, and I have to make it reverse. That's good. And the next thing is I make this face and front plane to be coincident. In this case they are already coincident, so it's done. Now obviously if I want to make a motion between this mechanism and this gear, I have to use a belt. A very handy feature in SolidWorks, belt and chains. So you go to assembly, you go to assembly feature, and belt and chain is the last feature. So you use this circle and this circle. So automatically it makes a chain. Obviously there are a few options here. So one of them is that there can be driven by the length, so we don't use that. So but now they are engaged, these two are engaged. I go and I select also create belt part, and I'll tell you later on why I do that. At this stage I have to save the part as what I thought. So let's go to assembly 4 and save all the parts. So it asks where I save. So these are because are the part of the design library. You can save it somewhere else. After it's done, so now look at what's happening here. I simply, by moving this gear, the rest of them is moving. The rest of the mechanism is moving, as you can see that. But now this is not a very realistic belt. What if I want to make it more realistic? So here is the belt option, and I go to the belt, which is a belt assembly, and then I go further down here. This is the actual drawing of the belt. I go and make an edit sketch on the belt, and then I go here to feature, extrude. I extrude thin feature. I would say the size of the belt is maybe 3 millimeter, and the rest of them is all good. You can increase the thickness to 30 and reverse the side, and that's exactly what you have here now. It's a realistic belt that you can see here. So by moving the belt, everything else will be moving, and look at here, the motion is there, so they're all connected. Okay, I want to bring also a rack here. So here is a rack, and again for the rack you have to pay attention. The same thing, you go to a module of 2, and the distance again in this case 20 would be sufficient. You want to make it a little longer here. The face would be 20. So the rest is fine. So here is what I have, and then I want to connect them together. So I need only one. Few mate I have to make. First of all, it's not a bad idea. First of all, you want to make this one parallel to a line here. I will go and I go to my sketch. I'm making a sketch, and that's only one way to do it. And in my sketch, I make a construction line, and that line is from this side to this side. So this line is constant, the position, versus that the gear is moving. First thing I do, I will say that this edge and this line is supposed to be in parallel. That's good. The next thing is I go to Advanced Mate and I make the width. This face and this face, they are between this face and this face. That's another movie. You see now it's moving it. It's in this. You can. I don't know why it didn't do it actually. Let's just try it again. I think it didn't do it. Let's go again. I select this face and this face to be between this face and this face. Maybe I didn't select. Okay. Now it's good. So you see it moves only in this position, nowhere else. Not quite what I wanted actually. I don't know. Still. But let's continue. And now I want to make go down here, and why this two doesn't work? Let's delete them both. That's kind of strange. Okay, in this plane. Okay, so we can do this. We can make this face and this face. Yeah, to be coincident. That works. Yeah, this is good. Actually, I think it's kind of illusion because now, yes, you can see that you can't even move it here. It's still in the same position. Even previously was working there because now by changing it, you move it in one plane only. Okay, let's just go to this plane and let's just get them close to each other. So in that case here, let me just use a simple distance, and I select this and this line again, and the distance here 40. Let's see, 40 works. A little more, 45. So you have to place it in the right. Yeah, it's the case. Here is good. Make it 45, and let me just go and hide this. Now I want to actually show you something. Each of these gear, like for example this gear, if I open it, I will see that this gear includes several parts, and I go to the cut teeth, and now I can go and I can show these lines. So these are the line that you need to use for rack and pinion. I change the position of this gear to a proper position, which is almost like here. Very good. And then I simply go to mate, rack and pinion, which is here. And of course for the rack I need to use maybe just a line here, this, and for the pinion I use this. So, and everything else is good. So, and I think I should use reverse here. Let's see if it's working correctly now. Oh, actually I shouldn't have used the reverse. It should be go back here. Same direction. Yes, I just go and unclick reverse, and then it's gonna be okay, which is okay. So now you can see that this rack and pinion is working perfectly. So if I move this, you can see easily by moving one gear, the other one moves too. Obviously, if you want to make it a little more realistic, you have to make this motion limited. So in that case here, you have to have another mate, the final mate, the very last mate, is you go to advanced mate and you use distance, and the distance between this face and this center. So let me just go a little further here. So it goes from maybe from 20 or maybe from 10 to 190, and that is what I have. So let's see if I move this here, goes to that point. Okay, let's see here. Let's just check the mate again. If I have it correctly, limit. Now there is some error here. Oh, it's good. Let me just go here again and see what I did on this. From 10 to 100. Let me see in motion here. Yeah, apparently should be working, but maximum and minimum. Maximum distance is, yes, okay. So what will happen is that there's this case is there's two possibilities. From here, it goes 10, and then it can go further down, and it can even pass through, become 190. I can show you what happens here. Let me just show it here. So if I move this one here, so let me just go here. No, SolidWorks doesn't want to cooperate, but so it moves here. So the distance now, it won't go more than 190. You can see that here. That's the maximum. But from this side, it can go further. So you see the limit is correct now. But if I want to push this one further, yeah, right now it's working actually. But sometimes it goes to the other limit. So when you do the mate, be careful that this distance and this distance, there's two possibilities. So 190, you can go past the limit and then go further, or it could be within this range that we have it here now. So this is the range of the motion now here, which works perfectly. Anyway, so I strongly encourage my students as well as anyone else to try to get more familiar. So there are other features here in mate that I can briefly explain that. So for example, when you go to mechanical mate, so we talk about two of them only. So the cam is very easy. You can make a cam shape, and then you have a pin, and then you connect the tip of the pin with the cam, and that motion by rotating a shaft in the cam can have up and down motion. Hinges, very simple. You have kind of half a circle shape, and then you have a rod, and we can make a motion of actual hinge. Universal joint, something for like a two yokes that want to be in contact. You can male and female parts, and then if there's a yoke between them, they can move. Otherwise, like an arm, they can have a universal motion. And a screw is very easy. You have a screw, and then you can define two axes for the screws, and you can define how far it goes down, how much of a revolution. But most of them, most importantly, is these two that we already explained. Well, thank you very much, and I hope this was helpful.